Hello everyone. In this lecture, we will discuss an example of a continuous review inventory system. As we know, the basic EOQ model somewhat unrealistic because it assumes a constant demand rate. In reality, demand rate usually varies from period to period. If the daily demand rate, say, varies from day to day, then the reorder point is also not constant, even if the lead time is constant. Consequently, the total demand during lead time cannot be predicted with certainty, and stock out may occur. This is why safety stock is usually added in order to protect against stock outs. A continuous review inventory model or fixed order quantity model can be used to design an inventory system when the demand rate and the order lead time are not constant. Let's see an example. A retailer sells a product that has a mean weekly demand of 150 units. The standard deviation of weekly demand is 12 units. Since the weekly demand has a standard deviation, that signifies that the weekly demand is not constant. The product is purchased from a supplier at a cost of $23 per unit. The supplier lead time is 2 weeks. The ordering cost is $64 per order, and the inventory carrying rate per year is 15% of the product cost. The retailer operates 52 weeks per year. There are 4 things that we would like to calculate in this problem. First, can we find the optimal order quantity for the product? Second, how many units should be maintained as safety stock if the retailer wants to have a cycle service level of 99%? Third, what is the reorder point? Finally, we also want to calculate the annual inventory cost, including the safety stock cost. This problem is rather simple because the lead time is still constant at 2 weeks. So the only variable here is the weekly demand that has a mean of 150 and standard deviation of 12. Now, can we find the optimal order quantity? Actually, there is not a simple formula for the exact optimal order quantity, but the textbook suggests to use EOQ as the order quantity for approximation. Knowing the average weekly demand is 150 units, then the average yearly demand will be 52 weeks times 150 units per week equal 7,800 units per year. Unit holding cost will be 15% of the unit purchase cost. So 15% of $23 is $3.45 per unit per year. The ordering cost per order is $64. Using the average yearly demand, the unit holding cost, and the ordering cost, the optimal order quantity using the regular EOQ formula is 537.951 units. We can assume that the retailer can use 538 units as the order quantity. Next, we want to calculate the safety stock, which is typically needed to protect the retailer from stock out during lead time. As we remember, average weekly demand is 150 units with a standard deviation of 12 units. The order lead time is constant here, equal 2 weeks. And the target or required cycle service level is 99%. In order to calculate the safety stock, we need to know the expected demand during lead time or average demand during lead time, which is simply 150 units per week times 2 weeks equals 300 units. Then we need to calculate also the standard deviation of demand during lead time, which is equal to the standard deviation times the square root of lead time. So lead time is 2 weeks. Consequently, the formula is 12 times square root of 2, which is equal to 16.9706 units. Then we can determine the value of Z by assuming normal distribution. In this particular case, for the lower tail of 99%, the value of Z is 2.326. Consequently, the safety stock will be Z times the standard deviation of demand during lead time, which is 16.9706. After we performed the calculation, we found that safety stock is equal to 39.4735 units. If we round it, say we can use a safety stock of 39 units. Once we know the safety stock, then we can determine the reorder point. So the reorder point will be the sum of average demand during lead time plus safety stock. The average demand during lead time is 300 units because 150 times 2. The safety stock has been determined equal 39 units. Then the reorder point will be 300 plus 39, which is equal to 339 units. Consequently, the retailer may use a reorder point of 339 units. In the last question, we want to calculate the annual inventory cost for the system. We are going to use EOQ cost calculation here as an approximation. So our AIC will be equal to average inventory level divided by 2 times H plus yearly demand divided by Q times S, and the cost of safety stock. So 538 divided by 2 times 3.45 plus 7,800 divided by 538 times 64 and plus 3.45 times 39, which is the safety stock. The total would be 1,990 and 48 cents. That's the annual inventory cost. The calculation is not really exact, but a very good approximation of the actual cost. This concludes the lecture. Thank you.